Well, good morning, everybody. So my goal here today is to present you what we have been doing in terms of marine heat flow in Mexico. There's been some action going on in the last few years. We've been learning a lot, and we are very proud, my team and I, to be part of this community. So I have two goals in this talk. So first is to showcase a little bit what I've been doing in terms of expeditions and why are we studying the Gulf of California. And then if I have enough time, I would like to present the results of our last expedition. I might rush through some of the slides, so apologies for that in advance, but if you have any questions, please feel free to meet me. Okay, so so as I said, so we are part of the Tectonophysics and Heat Flow Lab in CICESE, which is a research center in Baja California, Mexico. So as you might know, Mexico has the National University, UNAM, and also some research centers funded by the government, so CICESE is one of them. And I could say that with certainty that is one of the most important ones in the country. And so we have been exploring the Gulf for the last 10 years, and we are proud to have involved many students on it and have delivered papers and also graduate students with this program. And one of these things, one of the expeditions that we made was the expedition to the Pescadero Basin, which I will present you further on. And so here are some of the persons, actually, oh, sorry. Oops. Okay. So yeah, this is my team. Juan in the middle here is the responsible for pretty much of all our, development in this field in particular. And we try to make this bridge between marine heat flow and tectonophysics and geodynamic processes. So it's not easy, but as I said, we've learned a lot through the last years, and we are very proud to have formed this particular group. And as I said, I had the chance to take students to many important platforms, oceanographic ships, and so it's been a learning experience for them as well. The Gulf of California, as you might know, is an oblique rifting system. It's very famous in and around the world because of special characteristics. So it's, as I said, an oblique rift system characterized by a series of pull-apart basins which are linked by transform faults. And I will show you a map. I should probably start with this one. So we have a series of basins here. And from the Northern Gulf, we have Wagner Basin, Consac, Delfin, and then the famous Guaymas Basin, which has had pulled a lot of attention, and it's well studied, probably the best one. And then the southern basins, Carmen, Farallon, and which are not that well studied, are actually poorly studied, and then Pescadero and Alarcon basins, which have been studied the last years. So as I said, the Gulf could be divided grossly into the northern basin, which are well sedimented basins, and the southern basins, which are completely different, with starved basins in the southern Gulf, Pescadero and Alarcon being the ones that have been studied more. In the north, we have shallower basins that are characterized by thick sedimentary cover, whereas in the south, we have different stages of development of the basins, particularly the one that I will be presenting later, which already have, signs or evidence that the rupture has also begun. But in terms of development, we will say that Alarcon is the one that, Alarcon and Guaymas were the ones that were, in terms of the basin development, more advanced. Guaymas and Alarcon have already ruptured, and we have new seafloor there, for sure. Now, in terms of heat flow, as you will see, there are I will draw your attention to the continental heat flow in and around the peninsula and the northwestern part of Mexico. Orlando told us a little bit about the whole country yesterday, but only in continental terms. And then we have the marine heat flow, which are measurements, like direct measurements, and then some borehole data, which are the little triangles. You could see it's mainly related to the Northern Gulf, and these were realized or carried out by the Mexican oil company when they were doing their, looking for oil and in the 80s, pretty much. And some of the indirect also values from Curie depths and other proxies are shown in this figure. So as you can see, it might look like we are not, but there's enough data, which is true in some basins, but we're still, lacking a lot of data, especially in these southern basins, Carmen, Farallón, and also Gonzaga and Delfin. So apologies for the size of the points here, but really all the Northern Gulf, the measurements in the Northern Gulf are concentrated in and around the Wagner Basin. And I should also mention that there were previous heat flow measurements that we didn't start the whole of them, of course, but they were scattered measurements. And as somebody pointed out yesterday, it's just like with the boreholes, like you have several shallow boreholes. It's not as good as one deep borehole. So it's the same. So we cannot do much with these scattered values because we didn't have a way to interpret or use them in a meaningful way. So we started carrying out trying to develop some targets. So we developed, we targeted the Wagner Basin in the north. Then the Guaymas Basin was already, as I said, the most studied basin. So we had more heat flow here, but that was concentrated in and around the troughs only. And in Alarcón, there were some measurements, but here in Pescadero, there were practically none. So we started back in 2015 with the Wagner expedition, and so we were aiming to do high resolution bathymetry, but that never happened. But we actually did some a nice profile here around a seismic, actually following a seismic line, because the Northern Gulf is one of the areas that have a well seismic curvature. So we did a systematic heat flow transect here, and we actually confirmed that it's an area around the northern part of this basin that has a heat flow anomaly very high in the terms in and around 6 watts per square millimeter. So it's very high, and just so high that actually our probe was, above its, specifications. So we did some also coring and water sampling, and we actually did this paper, which is also Florian's PhD thesis, and we actually got, we used this equipment from PHYLAX and the Biolimbo heat flow probe, and it was a very successful campaign. I don't gonna go into the details too much because I know that my time is limited, but that's where we did the main profile, and then this is the main anomaly. And so we were trying to study as much as we could, but the problem here is that we don't have any bathymetry. So it's like if there's something down there producing this anomaly, we don't know yet what it is. So we are hoping we actually have a proposal to go back and do the bathymetry that will allow us to constrain much better this particular anomaly. But one of my PhD students, Peña Dominguez, has already worked on the seismics available, and this is the anomaly, as you can see. So this is heat flow versus distance. So it's a beautiful anomaly, and it's really interesting in terms of geothermic potential, because this particular basin is very shallow. We're talking about the water column being only 100 meters. So it's interesting. And also, somebody was asking yesterday, this is not that surprising since right here on the north, there's Cerro Prieto geothermal field, and further north, there's the Salton Trough. So as you know, we're following the southern tip of the San Andreas Fault that it's going into the Gulf. And so, well, Wagner Basin is definitely one of the most important systems. So this is the heat flow contour maps that my student worked on, and this is what we are hypothesizing that could be the responsible for the anomaly that we see. But still, as I said, we need further studies there. And then 2012 to 2015, along with Barry and the U.S.A, which is the State University of Baja California, we went to Pescadero Basin, which is right here on the south. And we were able to study it with high resolution bathymetry mapping with AUVs. And we also performed some push cores, and we discovered actually 2 bend fields, beautiful hydrothermal systems down there, and it's a very deep basin, 3.7 kilometers depth. And so we were able to do this with the ROV from the Embari ship, and also there was this paper that was one of the deliverables from this project. And later, we continued this effort. In 2018, we went back, and then this time, heat flow was on the table, which was very nice for us, because as I was explaining to somebody yesterday, in these kinds of expeditions, which are very expensive, ship time is gold, right? So all the scientists involved are really struggling to have some time to do their own research. And heat flow was important to them, but not that important. And so we have to share the leg with the biologists and microbiologists, and they were very, very keen of their time. But we ended up having the time to do enough. So here's the newly discovered hydrothermal bend fields, and so we focus on the bigger one, and did 3 transects along the bend field, which was the first heat flow survey in this basin, by the way. So from that expedition, we had a numerous, juicy production of papers, and that expedition was taken on Falkor, which is owned and managed by the Smith Ocean Institute, and these collaborations are key for us, because in Mexico, we do have in CICESE and at UNAM oceanographic ships, oceanographic vessels, but they are not equipped to do this kind of work. We don't have an ROV, we don't have an AUV, so for us, this is the way to go. I mean, these international collaborations allow us to do this kind of first-line science. And then later on, we were invited by the IODP to go back in 2018 to the Guaymas expedition. And well, if somebody wants to talk in detail about it, you can always go with Florian, because he's the expert on this. And so, well, they drill many cores that are available to us to study, and that's actually what Florian is working on now. And I have another PhD student that is also working on that data. So this expedition allowed the team to explore this ring bend area, which is a hydrothermal system as well. And the Guaymas Basin is very complex, and well, there's much to say now that we know better thanks to heat flow studies, like the IVP and also that drew the attention of MIT, Harvard, and the Woods Hole. So they invited us to go with them in the Rebel expedition to Guaymas again.
So, Raquel, 5 minutes.
No. I told you, I won't be able to present you the rest of it.
I'll give you 2 more. Read from the coffee.
Oh my God, the time flies here. So sorry.
As usual.
I know. This is so fun. Okay, so well, we went back to Guaymas, and then using the ROV, this is an important difference from the Wagner Basin because we were using the short probe, the 60 centimeters probe that were managed by both ROVs in the Rubel and in the Falcor. So in this case, there was a large systematic profile done in this particular area, which is very, very interesting. And at the end of last year, we were also in Antarctica. We were invited by the Royal Observatory of Spain. And so they were on board of the Sarmiento de Gamboa, which is the vessel for Antarctic research. And they were interested in performing some heat flow in Powell Basin and Bransfield Basin as well. So that was also a successful campaign and a really nice experience. We did use our equipment again, so that was a learning experience how much expensive and time-consuming and stressful it is to take this equipment all the way from Ensenada to the Patagonia area. But it was worth it, totally worth it. So yeah, I think the last expedition to Pescadero Basin, which was a continuation of the 2012 and 2015 efforts, we were lucky enough to take a lot of students with us. You know, it was still the pandemic times. We had to do quarantine and all of that in hotels. That was not fun, but it was very, very fruitful as well. Oh my God. We did some mapping, and we went to study the second bent field and perform also some transects there. So very, very interesting times for us in terms of marine heat flow and a lot of action. So we hope to continue that. Oh my God. Okay. So I'm just going to have to go really fast through all these slides. I'm sorry about that, and please feel free to find me if you need more details. But so the Pescadero Basin in the southern part, where the bent fields are, is a stretched modal pull-apart basin developed between the overlapping Central and South Pescadero Basins, transfer faults, excuse me. The basin is strongly asymmetric, and it's controlled by a transfer system of normal faults. The location of the bent fields, as I said, it's here, and then we have this inset where we show the AUCA field. So we didn't have any seismic around here, so it's difficult to perform heat flow and have meaningful results without seismics. But we did have some sub-bottom profiles, and so what we did is try to follow those profiles and follow the and did the transects along them. And we construct a model for the geothermal system of AUCA, a very simple one, really. So we were trying just to see if the fault had a big role into the transfer of heat and fluids, and that was probably the way that heat transfer was progressing here. So we ended up with a numerical solution as well to the conceptual model that kind of confirmed that if we solved the heat flow equation, we would find this anomaly, right? A thermic plume, let's say. And with this lateral circulation, we could easily explain why do we have the hydrothermal bent fields here. There in particular in AUCA. And so that the 2D temperature distribution and heat flow models are well correlated, and so this is heat flow versus distance, and oops, sorry, no, bear with me, yeah. So we compare both the numerical and analytical models, and we find a good correlation on between them.
So now you have your 2 minutes extra.
Okay, thank you. Okay, I'll finish, I promise. And so, so we have a good fit between the numerical solution and heat flow data is particularly poor near the fault and for fault field values. So right now we're working on trying to connect the two works, the 2018 and 2021 in fact, and there's some nice correlation with the biology there that we are taking a look at, and there's also a good correlation, well, interesting first preliminary conclusions between how the heat flow decays in U.S.A, which is a bigger field, and then how it decays on Jahma, which is the smaller field, and so we have found enough differences between them. So this is the final figure where we can see the difference, the points from U.S.A and Jahma and the laws they follow in terms of heat flow decay. So there's a lot to add to the conversation to see if there's a convective element to this. And so we're still working on it. So don't bear about, thank you for your time and patience.